Hello students, today we will discuss paper 9. The topic was fluid mechanics and properties of matter. In the first question, it is given that a 20 kg load is suspended by a wire of cross-sectional area A, that is 4.4 millimeter square. Converting it in SI unit, 0.4 into 10 power minus 6 meter square. What will be the stress produced? The stress can be given as F by A. Here force is the gravitational force, that is 20 into G, that is 9.8, divided by area is 0.4 into 10 power minus 6. Simplified, we will get 4.9 into 10 power 8 Newton per meter square. So option 2 is correct option. In question number 2, it is given that initially a body of mass m and density dB is suspended from a wire, and due to this the elongation in the wire is E. Now the body is completely immersed in a fluid. The density of fluid is given as dl. This fluid is non-viscous. What will be the elongation in the string in this case? The elongation can be given as delta L1 in first case and delta L2 in second case. Delta L1 is given E in this case. As the string remains same, the Young's modulus in both the case will be same. Y can be written as tension force divided by cross-sectional area divided by delta L by L. Here, for this case, the Young's modulus, cross-sectional area and length of string will remain constant. So we can say tension force is directly proportional to delta L, or delta L is directly proportional to tension force. The tension force created in first case will be due to gravitational force only. So tension force in first case will be mg. T will be mg. Let's say it is T1. In the second case, if we draw the free body diagram of the object, in the downward direction force acting is mg, and in upward direction buoyant force will act. So net tension force in upward direction will be mg minus buoyant force. Mg can be written as density of body into volume of body into G, minus, thus buoyant force will be density of liquid into volume of body inside. Here body is completely immersed, so it will be Vb into G. So tension force in second case will be Vbg into dB minus dl. Here T1 can be written as mass of body, that is density of body into volume of body into G. Now from this we can write delta L2 by delta L1 is equals to T2 by T1. So delta L2 divided by delta L1 is equals to T2 is Vbg into dB minus dl divided by T1 is Vbg into dB. This Vbg will be cancelled out, so is equals to 1 minus density of liquid divided by density of body. Elongation in first case is given E, so delta L2 will be E into 1 minus density of liquid divided by density of body. So option 1 is correct option. In question number 3, a cube is given of side 5 cm. It has upper face displaced by 0.65 cm. That means x for this is 0.65 cm. This is cube. Force is applied in this direction. Because of that, upper face is displaced by amount x. The tangential force applied here is 0.25 Newton. We want to find the modulus of rigidity. The modulus of rigidity eta can be given as F by E into x divided by h. Here force is 0.25. Height, that is side of cube, that is 5 centimeters, so 5 into 10 power minus 2. Area will be 5 square 25 into 10 power minus 4 meter square, and x is given as 0.65 centimeter, that is 0.65 into 10 power minus 2 meter. Simplify this, we will get eta is equals to 769.2 Newton per meter square. So option 1 is correct option. In question number 4, we want to find the Young's modulus of given wire. It is given that length of wire is 156 centimeter. Its diameter is 0.054 centimeter. So radius will be 0.027 centimeter, that is 0.027 into 10 power minus 2 meter, and it can be written as 1.56 meter. The average increase in length is given. Delta L is equals to 0.050 centimeter power minus 2 meter. The force applied is 1.5 kg weight, that is 1.5 into g. Let's take g is equals to 10, so that will be 1.5 into 10, so 15 Newton. Young's modulus can be written as F by A to delta L by L. A can be written as pi r square. R is given over here. Find the value. We will get y is equals to 2.002 into 10 power 11 Newton per meter square. So option 3 is correct option. In question number 5, we want to find the ratio of elongation produced in two different wires, that is delta L1 by delta L2, provided tensile force is same for both the wires. Here y can be written as FL divided by E delta L. As F is same for both the wires, we can write delta L is directly proportional to L divided by E into Y. So delta L1 by delta L2 can be written as L1 by L2 into A2 by A1 into Y2 by Y1. L1 by L2 is given 3:4. A1 by A2 is given 1:4. So this ratio will be 4:1, and Y2 by Y1 will be 2:3. Simplify this, we'll get answer 2:1. So option 4 is correct option. In question number 6, the ratio of diameters of two wires of same material is given as d1 by d2 is equals to n:1. The length of each wire is 4 meter. So L1 is equals to L2 is equals to 4 meter. On applying same load, that means force is also same, the increasing length of the thin wire will be, here as the material of both the wires is same, we can write y is equals to F divided by E delta L by L. Here Young's modulus will be same, force is applied same, length of both the wire is also 4 meter, so we can write E into delta L is equals to constant. So delta L is inversely proportional to E, and delta L is inversely proportional to radius square. So delta L2 by delta L1, here we have taken second wire as thinner wire, so delta L2 by delta L1 is equals to R1 by R2 whole square. So delta L2 by delta L1 is equals to R1 by R2 is equals to D1 by D2. So we can write N by 1 whole square. So delta L2 will be N square delta L1. So increase in length of thin wire will be N square times the increase in length of thick wire. So option 1 is correct option. In question number 7, it is given that the increase in length of steel wire is same as increase in length of copper wire. Here delta L can be written as force into length divided by area into Young's modulus. Here it is also given that force is same. So we can write L divided by A into Y for steel is equals to L of copper divided by area of copper into Young's modulus of copper. We want to find the ratio of Young's modulus of steel to the Young's modulus of copper. This can be written as length of steel into area of copper divided by length of copper into area of steel. Put the values. Length of steel is given as 4.7 and area of steel is given 3 into 10 power minus 6 meters square. Length of copper is given 3.5 and area of copper is given 4 into 10 power minus 6 meters square. Simplify this, we will get answer 1.8. So option 1 is correct option. In question number 8, the breaking strain for aluminum is given 0.2%. That means delta L by L into 100 is equals to 0.2. So we can write delta L by L is equals to 0.2 divided by 100. Now Y is equals to F by A into delta L by L. We want to find the minimum cross-sectional area required. So A will be F divided by Y into delta L by L. Force is given as 10 power 4 Newton. The Young's modulus is given 7 into 10 power 9 and delta L by L can be written as 0.2 divided by 100. Simplify this, we will get area of 7.1 into 10 power minus 4 meter square. So option 3 is correct option. In question number 9, it is given that a metallic ring of radius 2 cm and area of cross section 4 cm square is fitted into a wooden circular disc of radius 4 cm. Here we can see that the radius of metal ring is lesser than radius of wooden disc, so we have to apply some force. That means we have to stretch the metallic ring. The Young's modulus of the material of the ring is given 2 into 10 power 11 Newton per meter square. We have to find the force with which the metal ring is expanded. Y Young's modulus can be written as force divided by A into delta L by L. Here originally the radius of ring was 2 cm and we have to make it 4 cm. So delta L will be 2 cm. So F can be written as YE delta L divided by L. Y is given 2 into 10 power 11. Area is given 4 cm square. So 4 into 10 power minus 4 meter square. Delta L is 2 into 10 power minus 2 meter and L original radius was 2 cm. Simplify this, we will get force as 8 into 10 power 7 Newton. So option 2 is correct option. In question number 10, it is given that when a uniform wire of radius r is stretched by a 2 kg weight, so the force will be 20 Newton. The increase in its length, that is delta L1, is 2 mm. What will be the increase in length if the radius is made r by 2? Here y will remain same. Y is equals to f L by delta L into E. Y, force and length will become same, so E into delta L will be constant. So we can write delta L is inversely proportional to area, and delta L is inversely proportional to r square. So delta L2 by delta L1 is equals to r1 by r2 whole square. r1 is r and r2 is r by 2 whole square. So delta L2 is equals to 4 times delta L1, and delta L1 is given as 2 mm. So delta L2 will be 8 millimeter. So option 4 is correct option. In question number 11, it is given that a volume of 10 power minus 3 meter cube is subjected to a pressure of 10 atm, that is pressure 10 into 10 power 5 Pascal. The change in volume delta V is 10 power minus 6 meter cube. We want to find the bulk modulus. Bulk modulus can be written as delta P divided by delta V by V. Here delta P is 10 power 6 into volume, that is 10 power minus 3 divided by 10 power minus 6. So bulk modulus will be 10 power 9 Newton per meter square. So option 1 is correct option. In question number 12, a hydraulic press contains 250 liters of oil. We want to find the increase in volume, that is delta V, when it is subjected to pressure P is equals to 10 power 7 Pascal. Given the bulk modulus of the oil is 5 into 10 power 9 Pascal. V can be written as P divided by delta V. So delta V will be P into V divided by V. Pressure is given 10 power 7, volume is 250 liter, and bulk modulus is 5 into 10 power 9. Simplifying this, we will get delta V is equals to minus of 0.5 liter. Here, as pressure is increased, the volume will decrease. That's why delta V is negative. So option 2 is correct option. In question number 13, it is given that a rod has Poisson's ratio, that is nu, is equals to 0.2. If rod suffers the longitudinal strain, that is delta L by L is equals to 2 into 10 power minus 3, then what is the percentage change in volume? We want to find delta V by V into 100. Here Poisson's ratio can be written as lateral strain upon longitudinal strain. So lateral strain dr by r will be nu times delta L by L. Here nu is 0.2 and delta L is 2 into 10 power minus 3. So dr by r will be 0.4 into 10 power minus 3. Now delta V by V can be written as delta L by L plus delta A by E, as volume is equals to area into length for rod. Delta V by V will be equal to delta L by R. area is directly proportional to r square, so delta E by E can be written as 2 times delta R by R. So plus delta R by R. But in this case, as longitudinal strain is positive, the lateral strain will be negative. So dr by r will be minus of 0.4 into 10 power minus 3. So delta V by V can be written as 2 into 10 power minus 3 plus 2 into minus 0.4 into 10 power minus 3. Simplify this, we will get delta V by V is equals to 1.2 into 10 power minus 3. So percentage change in volume will be 0.12%. So option 1 is correct option. In question number 14, the breaking stress for a material is given as 10 power 6 Newton per meter square. The density of material is 3 into 10 power 3 kg per meter cube. We want to find the minimum length of the wire made of the same material so that it breaks by its own weight. The breaking stress for given rod to break by its own length is given as L rho G. We want to find the length, so length will be stress, that is 10 power 6, divided by density, that is 3 into 10 power 3 into G. G is taken as 10. Simplify this, we will get L is equals to 33.4 meters. So this is the minimum length of that wire due to which it will break down due to its own weight. So option 1 is correct option. In question number 15, the Young's modulus of brass is given as 10 into 10 power 10 and that of steel is given as 2 into 10 power 11. Young's modulus of brass can be written as 10 power 11 Newton per meter square. They both have same length, the same forces applied and extended by same amount. So all these three quantities are same. We want to find the ratio of radii of brass to the radii of steel. Your Young modulus can be written as force by area to delta L by L. Here F, L and delta L are same quantities, so we can write Y is inversely proportional to A and Y is inversely proportional to R square. So R square is inversely proportional to Young's modulus. So radius of brass divided by radius of steel whole square is equals to Ys by Yb. So Rb by Rs whole square is equals to 2 into 10 power 11 divided by 10 power 11. So Rb is equals to root 2 times Rs, or Rs is equals to Rb by root 2. So option 2 is correct option.